Hello students. Now we are going to discuss about divided differences. When the arguments that is xi in the data given are not equally spaced, then we use the differences which are called as divided differences. Here what we do is see f of we find out the normal differences either backward or forward. We divide that by the difference between arguments also. That is what is the divided differences. The normal difference divided by the difference between the arguments, that is xi. So that is called as divided difference. That is, we usually denote this by f of x naught x1, f of x1 x2, like that. So here I define the divided difference as follows. Let y is equal to f of x be an unknown function, I say, right, whose functional form is not known, but its value at n plus 1 points, namely x naught, x1, so on up to xn, are known. The divided difference of the first order for the points x naught, x1 is defined as f of, this is written like this only, f square within square brackets, it is x naught comma x1. So this is equal to what? It is f of x1 minus f of x naught divided by x1 minus x naught. So here, see, you can easily observe what is f of x1? It is y1. And what is f of x naught? It is y naught. So it is like y1 minus y naught over x1 minus x naught. Right. So it is like slope of the line joining x1, y1 and x2, y2, or x naught, y naught and x1, y1. So f of x naught, x1 is what? It is f of x1 minus f of x naught over x1 minus x naught. Similarly, I can define the higher order divided differences. So divided difference of first order is what? It is defined as f of in within square brackets x naught x1, which is equal to f of x1 minus f of x naught over x1 minus x. Right. Now the second order divided difference, I write this as f of x naught x1 x2. That is, I'm considering first three tabulated points x naught x1 x2. So what it is? It is f of x naught x1 minus f of x1 x2 divided by x2 minus x naught. That is the first order difference, the difference of the first order divided difference divided by x2 minus x naught. That is the last argument minus the first argument. So it is f of x naught x1 minus f of x1 x2 divided by x2 minus x2. That is 1 by x2 minus x naught times. It is f of x naught x1 is what? F of x1 minus f of x naught over x naught minus x1 minus f of x2, x1, x2 is what? F of x2 minus f of x1 over x2 minus x1. So if I simplify this, you get, we can get f of x naught is divided by, means I take LCM and I simplify this. So I get f of x naught divided by x1 minus x naught into x2 minus x naught plus f of x1 divided by x naught minus x1 into x2 minus x1 plus f of x2 divided by x1 x naught minus x2 into x1 minus x naught. Here, see what I have done. So x naught, if it is f of x naught, it is x1 minus x naught into x2 minus x naught. If it is f of x1 divided by, see, I subtract in the denominator, I subtract x1 with other terms, that is x naught minus x1, x2 minus x1. If it is f of x2 plus f of x2 divided by, it is x naught minus x2 into x1 minus x2. That is difference of x2 from the other 2 points, right? So this is second order difference. So like this, I can I can define nth order divided difference. So I need not worry about the properties. F of x naught x1 is same as f of x1 x naught. It is symmetric. I need not worry about this. And if the arguments are equally spaced, then it becomes the differentiation. That I need not worry about it. So I'm mainly worried about the formation of first order divided differences. That is difference tables, divided difference tables. See here x, then y. The x is the argument, y is the value of the function at x. So x naught, y naught, x1, y1, x2, y2, x3, y3, x4, y4. So this is the special representation of divided difference, first order divided difference. This is second order difference, divided difference. This is third order. This is the fourth order. So if I'm having 5 points, x naught, x1 up to x4, so 5 points are there. I can have the fourth order divided difference. So here, see, if you look at this, see, the f of x naught x1, that the first order difference of x naught and x1 is written in between y naught and y1. Similarly, f of x1 x2 is written in between y1 and y2. That is first order difference. F of square bracket x2 x3 is written as in between y2 and y3. Similarly, f of x3 x4 is written as x1 x3. So what is the f of x naught x1? It is fx1 minus fx0 over x1 minus x0. What is f of x1 x2? It is f of x2 minus f of x1 over x2 minus x1. What is f of x2 x3? It is f of x3 minus f of x2 over x3 minus x2. What is f of x4? It is f of x3 x4. It is f of x4 minus f of x3 over x4 minus x3. Then I write in between these two, I write the second order. It is f of x0 x1 x2. What it is? F of x1 x0 minus f of x1 x2 divided by x2 minus x0. Then f of x1 x2 x3, that is differentiation of this minus this divided by x3 minus x1. Similarly, f of x2 x3 x4 is what? This minus this divided by x4 minus x2. So like this, the difference of the first order divided difference gives me the second order divided difference. Similarly, f of x0 x1 x2 x3 is what? F of x1 x2 x3 minus f of x0 x1 x2 divided by x3 minus x0. That gives me the third order difference. Similarly, the difference between these two, that gives me the second, third order difference. Then this difference divided by x4 minus x0, that gives me the fourth order difference. So this is how we write the difference table. So I can give you an example here. See, obtain the divided difference table for the following function. If you observe here, see, x is not equally spaced, minus 1, 1, 4, 6. So difference between the first two is 1 minus of minus 1. 1 plus 1, it is 2. Difference between the second 4 and 1 is 4 minus 1. It is 3. Difference between fourth and the third argument is what? 6 minus 4, 2. So they are not equally spaced. So in such cases, we go for divided differences. So when x is minus 1, I form the table like this. X is minus 1, 1, 4, 6. Y value I write 1, minus 3, 21, 127. So the first order difference is what? Minus 3 minus 1 divided by 1 minus of minus 1. So it is 4 minus 4 by 2, it is minus 2. Then second order difference between these two, 21 minus of minus 3, that is 21 plus 3 divided by 4 minus 1, that is 3. So 24 divided by 3, it is 8. Then 127 minus 21, that is f of x4 minus f of x3. 127 minus 21 divided by 6 minus 4. So that gives me 53. Right. So next one. This I got the first order divided difference table -2, 8 and 53. Then second order difference table. What I should do? It is 8 minus of -2 divided by what I should do? It is 4 minus of -1. So it is 8 plus 2 divided by 5. So it is 2. Then difference of these two. So 53 minus 8 divided by it is 6 minus of 1, that is 6 minus 1, that is x4 x3 minus x1. So 53 minus 8 divided by 6 minus 1, so 6 minus 1, so that gives me 9. Then difference of these second order difference gives me the third order difference. So 9 minus 2 divided by x3 minus x naught. So 6 minus of -1. So 6 plus 1. So 9 minus 2 is 7 by 6 plus 1 is 7. So I get 1. So this is how we write the divided difference table. And in the next class, we are going to see how we make use of this divided differences in Newton's divided difference formula, and we get an interpolation formula of divided differences, which gives me the interpolation for unequal intervals. So far we have studied Newton's forward difference formula, Newton's backward difference formula for when the arguments, that is when the xi's are equally spaced. That is equally spaced means we can find out the common differences of two consecutive xi's that gives me the same value. Then only we say that they are equally spaced. So when they are equally spaced, we use either Newton's forward difference formula or we use Newton's backward difference formula. When they are not equally spaced, we use Newton's divided difference formula or Lagrange's interpolation formula. So in this, I have briefly explained you about the divided differences and how to write the divided difference table. So in the next lecture, I am going to study. I'm going to sorry.